1 billion years of a lifeless Earth. What was really happening there? For more than 1 billion years, Earth orbited the Sun without a single living thing on its surface. No plants, no bacteria, not even a single cell. The planet that today is covered in forests, blue oceans, and billions of living creatures was once a completely dead world. And during that empty stretch of time, a sequence of some of the most brutal events in the history of the solar system was unfolding. Events that turned out to be the absolute prerequisite before the first life could ever appear. 4.6 billion years ago, Earth had just formed from a clump of dust and gas swirling around the young sun. But this newly formed Earth looked nothing like the home we know today. 4.6 billion years ago, a blazing ball of lava. The moment it formed, Earth's entire surface was a sea of molten lava. Temperatures exceeded 2,000 degrees Celsius, hot enough to melt almost every type of rock in existence. There was no land, no ocean, and certainly no breathable atmosphere. All that existed was a giant glowing ball of magma, visible from a distance like a small star. This extreme heat didn't come from nowhere. It came from two sources at once: leftover energy from the planet's own formation process, and a relentless rain of asteroid and meteor impacts constantly slamming into Earth's surface. Each impact released energy equivalent to thousands of nuclear bombs, so the surface never had a chance to cool down. It was like a frying pan being heated non-stop from below. No matter how hard it tried to cool, the fire underneath never went out. 100 million years later, the collision that nearly destroyed everything. 100 million years after its formation, Earth experienced the single most catastrophic event in its history. An object the size of Mars, which scientists named Theia, slammed into Earth at tens of thousands of kilometers per hour. The collision was so extreme that most of Theia was completely destroyed, and a huge portion of Earth's own crust was blasted into space along with it. As a result, Earth's surface temperature spiked once again, turning the entire planet back into an ocean of lava for a second time. But out of this destruction, something important was born. The material blasted into space from the collision gradually gathered and compacted, forming one large object that would orbit Earth, the Moon. Without this brutal collision, the Moon might never have existed, and without the Moon, Earth's axial tilt would never have stabilized. Something that billions of years later turned out to be one of the key conditions for life to survive at all. 4.5 billion years ago, Earth begins to cool, but still far from hospitable. After the massive collision with Theia, Earth slowly began to cool. It took hundreds of millions of years for the outer crust to cool enough to harden into solid rock. But don't picture Earth at this stage as anything close to comfortable. The atmosphere surrounding Earth at the time was completely unbreathable, dominated by carbon dioxide, methane, and water vapor at extremely high concentrations, mixed with toxic gases like hydrogen sulfide. Surface temperatures were still well above the normal boiling point of water, meaning liquid water couldn't yet pool anywhere. So even though Earth's crust had begun to harden, its surface remained a barren volcanic wasteland, shrouded in toxic gas fog and constantly shaken by eruptions from beneath the surface. 4.1 billion years ago, a meteor storm that never stopped. Around 4.1 billion years ago, the inner solar system entered a period scientists call the Late Heavy Bombardment. During this phase, Earth, the Moon, Mercury, Venus, and Mars were pounded relentlessly by millions of asteroids and comets over hundreds of millions of years. Traces of this period are still visible today. The Moon's crater-covered surface is direct proof of just how brutal this era truly was. Earth almost certainly experienced impacts just as severe, if not worse, except its scars were long since erased by billions of years of geological activity. But hidden behind this constant destruction was something crucial. Many of the comets and asteroids that struck Earth carried ice and organic compounds from the outer reaches of the solar system. As a result, every impact that looked like a disaster was actually, little by little, delivering the raw materials life would eventually need: water and carbon-based molecules. It was like a delivery truck crashing into an empty house over and over again. Except each crash was unknowingly dropping off the building materials that house would eventually be built from. 4 billion years ago, the first oceans form. Once the meteor storm began to die down and Earth's surface had cooled enough, the water vapor that had been trapped in the atmosphere finally began to condense and fall as rain. But this wasn't ordinary rain. It fell non-stop for thousands of years, filling the basins across Earth's surface until the first oceans took shape. Water from this endless rain, combined with ice delivered by comets during the earlier bombardment period, finally created oceans that covered most of Earth's surface. But these first oceans were still far from friendly to life. The water was highly acidic, saturated with dissolved heavy metals, and much hotter than the oceans we know today. Likely reaching 70 to 80 degrees Celsius, due to residual heat still radiating from Earth's core and ongoing volcanic activity that had yet to settle down. 3.9 billion years ago, hydrothermal vents on the ocean floor. At the bottom of this hot, acidic, ancient ocean, underwater volcanic activity created cracks in Earth's crust known as hydrothermal vents. Through these cracks, superheated water mixed with minerals continuously surged into the ocean, carrying enormous amounts of chemical energy. It was in this extreme environment, according to many scientists, that simple organic molecules began to assemble. Amino acids, the basic building blocks of proteins, likely began forming around these vents, fueled by the constant supply of heat and minerals from deep within Earth. Over the following millions of years, these simple molecules kept colliding, reacting, and combining into increasingly complex structures. The process was slow, almost imperceptible, but it never stopped, happening continuously in the darkness of the ocean floor, a place sunlight could never reach. 3.8 billion years ago, the threshold of life. More than 800 million years after Earth first formed, the organic molecules that had been developing in the ancient ocean finally reached a critical tipping point. A cluster of molecules managed to form a structure capable of protecting itself from its surroundings, a simple membrane, while also being able to copy its own chemical information. This is the most basic definition of life, a system capable of sustaining and replicating itself. This first organism was nothing complex. It was far smaller than a single grain of sand, lived in the darkness of the ocean floor, and depended entirely on chemical energy from hydrothermal vents rather than sunlight. But from this single tiny point, every form of life that has ever existed on Earth, from the simplest bacteria to human beings, can ultimately trace its origin back to that empty billion years. So what was really happening during that more than 1 billion years of a lifeless Earth? It wasn't wasted emptiness. Every phase, the ocean of lava, the collision with Theia, the brutal meteor storms, the hot, acidic ocean, turned out to be a connected chain of cause and effect, carrying Earth step by step toward the point where life finally became possible. Without the collision with Theia, there would be no moon to stabilize Earth's axis. Without the brutal meteor storms, there wouldn't have been enough water and organic molecules delivered to the surface. Without the hot oceans and hydrothermal vents, there would have been no place for simple molecules to evolve into the first organism. The Earth that looked like hell for 1 billion years was, in fact, quietly assembling every condition needed to give birth to life. And from that single tiny organism at the bottom of an ancient ocean, billions of years later, came every living creature that has ever breathed on this planet.